So students, today we will discuss about the noise and control, which we are discussing about the previous class and which is the continuation of the previous class. The module is 5 and the lecture number is 24. Okay, so what are the objectives of the class, today's class? First of all, we can know what is L10 index. Next, we can discuss about the equivalent noise levels, that is denoted by the LEQ. Next, we will discuss about the noise threshold limit. What do you mean by noise threshold limits? And at last, we will see what are the physiological effects of the noise, or what are the effects of sound pollution. Okay, so these are the some of the topics that we will discuss today. Now, this is a recapitulation of the previous class. So, in the previous class, what we have discussed, we have defined the noise. That means how we can, what do you mean by noise, that we have defined. Now, some of the characteristic parameters also we have discussed. Okay, and classification. We have seen how we can classify the noise, and also we have seen what is decibel unit. That is very renowned unit of the intensity of sound, that is decibel unit. Okay, so these are the topics that we have covered in the previous class. Okay, so noise, generally we have seen sound, and there is a difference between sound and the noise. Generally, sound is a wave function, right? So what will happen, wave function, that means the all the characteristics, parameters also it will have, like the wavelength, the amplitude, the frequency, the intensity, the pressure. So all these also we have for the sound wave function. Now what will happen, while this wave function will not maintain the periodicity. So what will happen, that time the sound will create the noise, and that is called by that is called by sound pollution or noise. And noise is very unpleasant and unwanted sound. Okay, generally what we are saying, this is the musical sound. Why? Because the wave function, whatever from the musical sound, whatever wave function we are getting, that is periodical. Understand? So that is constant. The wavelength, the amplitude will be constant. But for noise, what will happen, the sound wave, at once it will, the amplitude will be very high. Okay, after that the amplitude will be low. So there will be no periodicity will be maintained for the noise. So that is why noise is very unpleasant. Now, if the sound level, sound intensity level, that is the decibel unit, sound intensity level is higher than 130, that will cause the what that will cause the biochemical, some of the biochemical effects on us. Okay, so generally up to 100 decibel we can, the sound will be bearable for us. But after 100 decibel, the sound will become the pollution. So and for that we can have the headache, for that we can have the some mental disorder diseases. Okay, so these are the some of the effects. Now, classification of noise. Now, noise, we have seen that noise are of three types. One is what? Yes, of course, that is the transport noise. Second one is, yes, the second one is the occupational noise. And the third one is the neighborhood noise. So there are three types of noise that we have. One is transport noise, one is occupational noise, and one is neighborhood noise. Now transport noise are of three types. Like, first of all, we have the road traffic noise. That means the surroundings, in our surroundings, in the road, whatever the noise, we are exposed to the noise. That noise is called by the what that noise is called by the road traffic noise. Next, air traffic noise. While during the time of the landing, during the time of the takeoff of any aeroplane, what will happen? The noise will created, and that noise is called aircraft noise. And rail traffic noise also we have, like by the horn, by whistle. So these all created the noise, and which is called by the belongs to this category, that is railway traffic noise. Okay. Now, occupational noise mainly like whatever, like from industry, factory, from any type of institute, marketplace. So from these places, whatever noises are created, that is called by occupational noise. And the last one, that is neighborhood noise. Like right now I'm discussing with you, and beside just my room, if someone is listening the music very in a very high volume, so that will belongs to be a neighborhood noise. Understand? Because that much sound level I can't bear. So that is why that is called by the neighborhood noise. Now, decibel unit is very important, because with the expression of the decibel, based on this expression, there are so many problems you have to solve in your exam. So you have to memorize the expression. What is the expression of the decibel? Generally, decibel unit is the intensity unit. Okay, excuse me. Actually, this is the ratio. Decibel equals to 10 log 10 I by I0. I is the measured in the intensity of the sound that we are exposed to, and I0 is the reference intensity. What is reference intensity? The minimum intensity that we can hear, that is audible to us. Like that, the value of the reference intensity is 10 to the power minus 12 watt per meter square. This is the unit of the sound level by intensity. Okay, so watt per meter square, the reference intensity will be 10 to the power minus 12. Okay, so up to these are the topics that we have discussed. This is just a glance. I'm giving you a glance so that you can remember what we have discussed in the previous class, because this class is also the continuation of the previous class. So these are all the things you should remember. Okay. Okay, now today we will discuss, that is L10 index. Very important. Okay, L10 index is defined as it is sum of the arithmetic average. Okay, now what will happen generally in the road traffic, like road traffic noise? There are so many vehicles we have. There are so many different sound levels that we are exposed to. So what we have, that is L10 index, it is the arithmetic average hourly values of the noise level which is exceeded for the 10% time. Whatever the permitted value, from that permitted value it will exceed, it will beyond that permitted value up to 10% times over 18 hours. For the 18 hours, from 6 a.m. to 12 p.m. So for this duration, what is the arithmetic average hourly values of the noise level, which is 10%, 10% time greater. Okay, so that is called by the L10 index, and generally this unit is very renowned and used generally in the UK for the road traffic noise, measurement of the road traffic noise. Okay, so this is called L10 index, and generally this is for the 18 hours. Okay. Next one is equivalent noise level. Now, as I told you, while we are we are facing the road traffic noise, what will happen? There are so many vehicles, so many sounds that we are exposed to. Now, what will happen? Here we are doing the weight average. We are taking the weight average of the sound level over a specific time span, and that is called by, that is represented as the L equivalent. Okay, now what will happen, and given in the dBA unit, right? Excuse me. Okay, so what will happen, for the time of the measurement is specific and measured for a short duration, usually when the noise level is most prominent, while the noise level is like in a weekday working hours. While the working hours, we have so many sounds where we are exposed to. Okay, for that duration, what will be, we are taking the weight average of the sound levels. Okay, if the measurement is done for different time duration, the value will be different. Very good. And if the measurement is done for a specific periodic time but in different place, also the value will be different. Okay, so equivalent noise level will be time specific and zone specific, right? So generally this is used for the measurement of the noise level in the industry, in the traffic areas. Okay, but road traffic, for the road traffic noise levels also, this is very general unit for the measurement of the noise. Okay. Okay, now next topic is, that is noise threshold limit value. Okay, so noise threshold limit value, uh, these are the, look at the table, these are the sum of the noise levels, right? 80 decibel, 85 decibel, 90 decibel, 95 decibel, and these are the hour per day, the duration of the exposure of this decibel sound per day. Understand? So here you can see, for 80 decibel sound we can hear for 16 hours per day. Okay, this is the permitted level. For 85 decibel, the duration is 8 hour. For 90 decibel, the duration is 4 hour. For 95 decibel, the duration is 2 hour. For 100 decibel, it is 1 hour. You can see, look, the for 80 decibel, it will be, if it is 16 hour. For 85, if we increase the decibel by 5, then it will be the hour per day, the duration of the hours per day, that will be just half. Okay, so 80, for 80 decibel, you can remember like this way. Don't memorize this table, just remember one thing. For 80 decibel, we have 16 hour per day. This is the permitted level. So if we increase 5 by 5, the sound level, like 85, that means 16 hours will be divided by 2, that is 8 hours. For 85 decibel, the 8 hours will be the permitted value. Again, the for 90, what will happen? The 4 hours will be the permitted value. For 95, 2 hours will be the permitted value. For 100, 1 hour will be the permitted value. For 105, half an hour. And for 110, we have the 1/4 hour. Okay, so thus you can remember the noise threshold limit. That means at this limit, we can hear the sound. Now if the limit will be whatever noise is creating, if that is beyond the noise threshold limit, that means that will harm us, that will be affect that time will be affected by the sound pollution, understand? So that time we will have some of the serious biochemical effects, while the noise level will be the beyond the noise threshold limit value. Okay, so this noise threshold limit also we can express as a equation, that is C1 by T1 plus C2 by T2 plus dot 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 Cn by Tn, where Cn, what is Cn? Cn indicates the total duration of the exposure. Whatever sound we are exposed to, that is the total duration. Like we are exposed to 90 decibel for 4 hours. So the Cn value for the 90 decibel sound will be 4 hours. Okay. Now, if the and Tn indicates the total duration of the exposure permitted at that level. That means Tn means the permitted at that exposure, like at 95 decibel, what will be the exposure time, permitted exposure time? That is also for the 95 decibel, that is the 2 hours. For 2 hours we can hear the 95 decibel sound. Okay, but here I'm saying you ki 95 decibel for 4 hours are creating. So Cn value for the 95 will be 4 and Tn value will be the 2. Understand? So this is a noise threshold limit when daily noise exposure is composed of 2 or more periods of noise exposure of different levels, their combined effects. Then we have to yes, we have to their combined effects we can express like this way. Okay, what will happen? Yeah, while we are exposed to the road traffic noise, there are so many noises are there for which we are exposed to. So what will happen? All the we have to sum up all the noise levels, and then we have to see if that noise threshold noise levels are beyond the threshold limit or not. If it is within the limit, then it's okay. If it is beyond the limit, that time we have to make some we have to take some steps to stop the pollution. Okay, so this is the importance of noise threshold limit values. So based on this equation Cn C1 by T1 C2 by T2, okay, based on this equation you can have this so many problems. Okay, so while this summation will be greater than 1, while this summation will be greater than 1, what will happen? That time you can say that the noise, whatever noises are created, all if we sum up all this, and that will obviously beyond the threshold limit. So that time we have to take some steps. Understand? So this is the utility of using this expression, and based on this expression also you can have so many problems which we will do next. Okay, so look at the question. This is our first question, first problem. In a work area, noise levels are read as 95 decibel for 2 hours, 80 decibel for 2 hours and 90 decibel for 4 hours. Find out whether the noise threshold limit value is within the permissible limit or not. Okay. So, in a work area, whatever the noise levels are that are given, that is for 95 decibel. 95 decibel is for 2 hours. 80 decibel sound we are they are creating, that is creating for the 2 hours, and 90 decibel for the 4 hours. Now you have to find out the noise threshold limit. Okay. So these are the values are given, data are given first. Check for 95 decibels. So C1 value, that means the hour, the duration of the exposure, actual exposure. That means 2 hours for 2 hours. And what is T1? T1 is the permitted value of the 95 decibel. For 95 decibel, what will be the permitted value? That is the 2 hour again. Okay. Now for 80 decibel, C2, that is 2 hours, and what is the permitted level? That is 16 hours. And for 90 decibel, C3 is the 4 hours and permitted level is also 4 hours. Now we will see either the noise threshold limit, whatever noise is created into that work area, this is within the limit or not. Okay. So again we have to use this equation, that is C1 by T1 plus C2 by T2 plus dot 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 Cn by Tn. So we have to do this summation. All the values we know. We know what is Cn and what is Tn, that is we know now. And hence, so what will happen? We all know, so what is the value of C1 T1? Already the data are given. That means 2 by 2 plus 2 by 16 plus 4 by 4, and it will give you 2.018, which is greater than 1. So obviously the limit, the noise level is beyond the permissible limit, as it is greater than unity. As it is greater than unit, that is why what will happen? It is permissible limit, beyond the permissible limit. Okay. So just forward, move to the next question. Okay, the given data are given 4 hours of 80 decibel exposure, 2 hours of 90 decibel exposure, and 2 hours for 85 decibel exposure. Now we have to find out again the noise threshold limit, and whether this limit is within the permissible limit or not, that also we have to check. Okay. So these are the data are given, that is for 80 decibel, C1 is given, that is 4 hours. C1 is 4 hours. Okay. So 4 hours. T1, T2, that is the permissible limit, is permitted value is 16 hour for the 80 decibel. For 90 decibel, C3 2 hours. Here C2 is the 2 hours and permitted level is 4 hours. For 85 decibel, that is again the 2 hours and the permitted level is 8 hours. So these are the data that is given. Now again we have to use the equation C1 by T1 plus C2 by T2 plus dot 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 Cn by Tn. All of you know Cn is the total duration of the exposure and Tn is the total duration of exposure permitted at that level. Okay, so that means look, 4 by 16, right? 4 by 16, 2 by 4 plus 2 by 8. So total is what? Exactly, total is equals to 1, equals to unity. So what? Yes, the noise level is within the permissible limit, as it is equal to unity. If it is equals to unity, or if it is less than unity, so it's okay. The noise level will be the permissible limit. Okay. Okay. Next question. So given 4 hours of 75 decibel exposure, 2 hours of 100 decibel exposure, and 2 hours for 85 decibel exposure. These data are given. Now again you have to find out whether the noise threshold limit value is within the permissible limit or not. So these are the data are given. Now 75 decibel sound. So whatever table we have drawn or we have checked in that table, the 75 decibel is not there. Actually for the 75 decibel, the permitted limit is infinite hours. Okay, and the C2 value is given, that is 4 hours, right? For 75 decibel, right? For 100 decibel, it is C2 is the 2 hours, and permitted level is, it should be T3. The permitted level is 1 hour, right? Okay, and for 85 decibel, it is the noise exposure level is 2 hours, and the permitted level is 8 hours. So these are the data are given. Sorry. Now again we have to use this equation, C1 by T1 plus C2 by T2 plus dot 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 Cn by Tn. All you know now, what is Cn and what is Tn. Hence what will happen, 4 by infinite plus 2 by 1 plus 2 by 8. So the summation will be 2.25, and which is greater than 1. So obviously the noise level is beyond the permissible limit, as it is greater than unity. Okay, so these are the some of the problems that you have related to this equation, or related to the noise threshold limit. Okay, so noise threshold limit. So this portion you have to practice very well, otherwise you cannot solve the problem, because it is very confusing. What is Cn, what is Tn? So that's why you have to practice the problem again and again, otherwise you cannot solve the problem and you cannot score full marks. Okay. Now next question is our, in a work area, if two machines produce 50 decibel sound each simultaneously, what will be the total intensity of produced sound? So these type of problems we have done, you can remember in our previous class. Okay, so 50 decibel sound, that means you have to memorize what is the unit of decibel, what is the expression of the decibel. Decibel equals to, you all know, sorry, 50 decibel is given. So yeah, can you remember this equation? Decibel equals to 10 log 10 I by I0. What is I? I is the measured intensity, and I0 is the reference intensity. Okay, so this decibel, by using this equation you can solve this question very easily. So we have two machines which will produce a 50 decibel sound. That means first of all we have to find out 50 decibel sound means what is the intensity, measured intensity of that sound level. Okay, so I0 value, this is the reference intensity, that is 1 into 10 to the minus 12 watt per meter square. Okay, this is the unit. Now this will be the equation, 50 equals to 10 log 10 I by I0. Okay, so this 10 we can divide this 50 with the 10. So 5 equals to log 10 I by I0. Now if we want to remove this log, what will happen? Look at the look at the screen, that this base, whatever the base is, the base will come here, and whatever we have in our left hand side, that will come to the power of that base. Okay, that is why it's 10 to the power 5, that is equals to I by I0. So next is I equals to 10 to the power minus 7 watt per meter square. So this intensity is produced by only one machine. Now here we have to calculate the total intensity. That means if we just multiply with the 2 into I, that will give you the total sound intensity, produce sound intensity by the two machines, and that is 2 into that will be the 2 into 10 to the power 7. Okay, so this is our answer. So these type of question also you can have from this chapter. Okay, so first of all you should read the chapter very well and memorize the problems, memorize the expression, equations, which equation is you have to use for solving the problem. That equations you have to first memorize. Okay. So, the last topic of this chapter, that is the effects of sound pollution. So, what are the effects? We know a sound of 65 decibel is the noise level for the conversation heard at a distance of 1 meter. Okay, sound of 110 decibel. 110 decibel, if it is greater than 100 decibel, that will gives us the discomfort. Okay, we will feel uneasy, and if it is 135, that time we will that is very painful, and we will have some of the biochemical effects on us. Okay, a sound level in the range of 110 to 150 affects respiratory system, cause of physical control, and other psychological changes might occur. Loud sounds can cause an increased secretion of various hormones of the pituitary gland and leading to increased blood sugar level, reducing immunity system, okay, and affecting our liver, heart, brain, and kidney. Noise affects mental capability, thereby reducing our concentration. Also, it can causes some of the chronic headache, and thereby reduce our work efficiency. So, noise level caused of deafness also. The hearing, so all of us should aware of this thing, that we should not use the sound which is higher than 100 decibel. There is so many occasions we can see in some places, like during the puja time, during some occasions, the loudspeaker music playing, so that we should not do, because that is affecting all of us. So we should control that pollution, we should stop that pollution, otherwise it will be harmful for us only. So we have to take steps for our sustainability, understand? So that is why we have to stop the sound pollution. Okay, now this is the quick review whatever I have taught today. So what is the permitted hour per day for the 100 decibel sound level? So first you have to memorize whatever I have taught you, whatever I have discussed, and then you will give I will give you 10-second time. You have the 10-second time, just remind the thing and then answer your question. So your time starts now. Yeah, your 10-second time is over. Yes, obviously the answer is 1 hour per day. So for 100 decibel sound, the permitted level will be 1 hour per day. Only for 1 hour we can hear that sound, that 100 decibel sound, and beyond that, that is a permissible, beyond the permissible limit, and that will have, that time we will have some of the biochemical effects, the harmful effects on us. Okay. So this is again the recapitulation. We have discussed about the L10 index. We have also seen that what is the equivalent noise level. No, this is not, we have already discussed, that is in our previous class. Okay, noise threshold limit. Yes, we have today, we have discussed about the noise threshold limit, and also we have discussed about the physiological effects of noise pollution on us. Okay, so all these topics we have covered, so all are the checked. So students, please follow my classes, and also you have to practice the problems regularly, otherwise you forget about the forget about the equations. Okay, and in your exam time you cannot solve the problem, because these problems are very easy if you just remember the equation. Only by putting the data you can get the full marks. So you have to be very careful about while doing the problems. Okay, and practice the problem regularly. So thank you, students. Have a good day.